Preparations are already underway for missions that will land humans on Mars in a decade or so. But what would people eat if these missions eventually lead to the permanent colonization of the red planet? The recent discovery of liquid water on Mars, which adds new information to the question of whether we will find life on the planet, does raise the possibility of using such supplies to help grow food. But water is only one of the many things we will need if we're to grow enough food on Mars. The future of Mars habitation requires freshly grown fruits, vegetables, and grains. But how do you farm on a poisonous, deadly planet like Mars? Let's find out. Welcome to Space World. In today's video, we are going to talk about how humans will farm on the red planet. So if you want to know more about it, then stay with us until the end of the video. Plants are hardy things, but they have some essential requirements. To grow well, they need warmth, reasonable atmospheric pressure, and protection from harmful radiation. Those things would be a challenge to provide on Mars, except for the fact that humans need all of them as well. The simplest solution would be that whatever habitat you build to house astronauts on Mars, you also build to house all the crops. Add some simple LED lights, and the astronauts can easily tend to their plants as they grow. Adding lights should counteract any effects of Mars's lower gravity, since even in zero gravity, plants naturally grow roots away from light sources. The sealed environment even has the advantage that you can control conditions like temperature and humidity. Weimer Vomelink, a plant breeder and ecologist at Wageningen University, who is one of the leading researchers on agriculture on the Moon and Mars, told Digital Trends that growing plants in space is actually very comparable to city agriculture, the movement to grow food efficiently in urban settings. Often that's accomplished by setting up sterile environments in indoor habitats with LED lights. In principle, he said, that's something you can do on Mars, or in the desert if you want to, or in the city. The biggest barrier to growing crops on Mars, though, is the lack of something seemingly simple: good old-fashioned dirt. Soil on Earth is full of living organisms, as well as certain minerals like phosphorus and potassium that plants use. Mars doesn't have soil. Instead, it has a dead, dusty material called regolith covering its surface. We don't know the exact details of what this regolith is composed of, and it might have different compositions in different regions. But we do have a rough idea of what's in it, which has allowed NASA to develop a regolith simulant. This is essentially a recreation of Martian soil based on our current knowledge of the planet's surface. Around a decade ago, Vomelink wondered if the simulant could be used to grow crops and looked into the subject. What I found out, he said, much to my surprise, I must say, is no one ever tried that. So he started planting seeds in Mars, Moon, and Earth soil to compare their growth. In his first experiments, Vomelink expected plants would struggle in the Mars simulant. It's a very nutrient-poor soil, he explained. It has no organic matter in it, and it contains heavy metals that could prevent plants from germinating. My expectations were very low, he said. His team planted 4,200 seeds of 14 different species, expecting that most of them would die. But the results were very different from what the researchers predicted. Almost all the seeds germinated, some of them within 24 hours. This actually caused problems, Vomelink said with a laugh, because the team suddenly had to tend to a huge crop of over 4,000 plants. The plants required a lot of careful watering, because the regolith is hydrophobic, meaning it doesn't absorb much moisture, so future Martian farmers will need plenty of water to keep their crops growing. And while the plants did grow in the Mars regolith simulant, they reached only a few centimeters high and didn't produce anything edible. To get plants to grow to a full size and produce vegetables, you need to add nutrients. Now, a key component that Mars soil is missing, as far as plants are concerned, is organic matter. Organic matter is a particularly important source of nutrients when broken down by bacteria, which means we'll need to add bacteria to future growing regions as well. Fortunately, as walking colonies of microbes, humans are bristling with bacteria. So although it is a rather unpleasant concept, we do have a way to acquire them. The most efficient method would be to preserve the urine and feces produced by astronauts on their months-long journey to Mars, then add it to the regolith to cultivate bacteria. Once your Mars regolith is enriched with nutrients, organic matter, bacteria, and worms, you can start planting seeds. Seeds can be brought from Earth without too much trouble, as they're small and light. But in addition to nutrients, one of the concerns about the safety of Mars soil is the presence of dangerous heavy metals. It's not only zinc, which we need a little bit of, but also cadmium, lead, mercury, all things you don't want in your food, Vomalink said. However, that isn't necessarily as big a problem as you might think. That's not really different from Earth, he pointed out, as heavy metals can be found in our soil too. The issue is whether these heavy metals are bound in a way that prevents them from being released into the soil and subsequently absorbed by plants. The good news is that when vegetables grown in the stimulant were analyzed, they were found to be safe to eat. Heavy metals were below dangerous levels in all the food, and in some cases, the levels were even lower in the regolith-grown vegetables than in the vegetables grown in regular potting soil, perhaps due to pollutants like car exhaust contaminating the soil here on Earth. Moreover, there is also a concern about how acidic the soil is on the Moon and Mars, which could limit the plant's ability to access another essential molecule, phosphate. A new area of research being considered is whether adding certain types of fungi to the regolith could solve this issue. We can take fungi with us to Mars that can grow actually in rocks and release phosphates, Vomalink suggested as a future avenue for exploration. They live in symbiosis with the roots of the plants. Apart from all of this, perhaps the biggest barrier to growing food safely on Mars is the issue of perchlorates, chemicals found in the regolith that are toxic to both humans and plants. These are so dangerous that they aren't included in stimulant samples for health reasons. Recent research has suggested that the presence of these perchlorates in the regolith might be more of a problem than previously realized. When researchers took regolith stimulant and added calcium perchlorate in amounts similar to those found on Mars, plants weren't able to grow in it even when extra nutrients were added. This doesn't mean we have to give up on the dream of Mars-grown food, though. Andrew Palmer, the Florida Institute of Technology senior author of the study, told Digital Trends in an email that while the presence of perchlorates on Mars is a challenge for food production, it isn't a deal-breaker. It should be possible to introduce microorganisms or specific plants into the ecosystem to clean the toxins from the regolith in a process called bioremediation. Such helpers are common players in our ecosystems on Earth. There is no reason we should ignore their potential to contribute to the ecosystems we are designing for our Martian colonists, he said. The presence of perchlorates isn't necessarily all bad news, though. Fackrell pointed out that having bacteria consume perchlorates to clean the soil would produce the useful byproduct of oxygen, which could be a part of a sustainable system for meeting astronauts' needs. Perchlorates represent a very real challenge. However, they also present opportunity to be turned into a resource for oxygen. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.